Hello, everybody, and welcome to another episode of the Extreme Performance Series. Today, we're going to get to talk with Lon and Uday about some ML AI topics. Uday, could you go ahead and introduce yourself real quick?
I'm Uday Kurkure. I'm the performance engineer at Broadcom. I have been doing AI ML for the last 10 years, and that has been my passion.
And Lon, how about you?
I have been working at Broadcom, specifically VMware, for over 10 years. Work on AI and GPU virtualizations.
Excellent. And so both of you have been on the series before, so it's really exciting to have both of you in the same video this year together. So, Uday, I think you're going to go first. Why don't you go ahead and start things off?
We are going to talk today about MLPerf Inference version 5.1 and how it works in VCF when we virtualize all the benchmarks. We partnered with SuperMicro, Dell, and Intel. Our MLPerf Inference v5.1 results show that when you virtualize the AML workloads, you get near bare metal performance. In addition, virtualized configurations use fraction of the bare metal resources. That means you can consolidate more VMs or other workloads on the same host with full isolation. Fully isolated fractional vGPUs are available only in the virtualized environment. VCF combines the power of NVIDIA GPUs, NVIDIA AI enterprise software, CPUs, and VMware's private AI foundation with the data center management benefits of virtualization. Now let's do a deep dive into MLPerf Inference 5.1 performance with Direct Path IO, NVIDIA 8X B200 performance in VCF. Direct Path IO is also known as a pass-through mode. We run the same benchmarks on bare metal as well as in the virtual environment. Our system was SuperMicro, the GPU server. You can see the picture of the liquid cooled host on the left side of this slide, where you can see the ducts going in, and that's where the liquid goes in and comes out. That cools the GPUs. On the virtual side, we only use 192 out of 384 cores. That leaves 192 CPU cores available for other virtual machines or workloads with full virtualization. And this is the benefit of virtualization. Both the systems had 8x NVIDIA B200s with 180 GB of HBM3E. On the virtual side, the GPUs were in the direct path IO or pass-through mode. All the GPUs in both the configurations were connected by NVLink and NVSwitch. On the bare metal side, the host had a 2.3 terabyte memory. On the virtual side, the host had 303 terabytes of memory, out of which we only allocated 2.5 terabytes to the inferencing virtual machine. Remaining could be used for other workloads. This chart shows the normalized throughput with respect to the bare metal performance. X-axis is the different benchmarks from the ML Commons, and the Y-axis is the normalized throughput with respect to the bare metal, and higher is better. You can see that we selected different benchmarks from different machine learning domains. Large language model, Llama 3 with 405 billion parameters. That's a pretty big model. And we did the benchmarking in server mode as well as in the offline mode. And we see that we deliver bare metal performance for even large language models, which are as large as 405 billion parameters. Our next benchmark is stable diffusion. And stable diffusion is text to images, which is a very hot area these days. Everybody is playing with Sora or Grok or Gemini to create images from the text prompt. And here also, we deliver near bare metal performance in both the server mode as well as the offline mode. And the difference between server mode and offline mode is, in the offline mode, the query comes one at a time. And in the offline mode, all the queries are given to the GPU server at the same time. And the last benchmark is the Whisper. And Whisper is a speech to text benchmark. And here also we deliver near bare metal performance. This is the power of virtualization. It delivers near bare metal performance using only fraction of the resources with full isolation. And you get all the benefits of virtualization.
So Uday, I've got a quick question for you. On these tests, with the B200 GPUs, the B stands for Blackwell. Is that correct?
Yes, the B stands for Blackwell.
And those are the most recent, most powerful NVIDIA GPUs on the market. Is that also correct?
Blackwell is the most powerful GPUs on the market, but there are many versions of Blackwell, right? There is a Blackwell B40, which is used for the VDI environment as well as, but I think even though it is meant for VDI, you could do machine learning on it as well. Then there is a B200, which we use, and then there is a B300, and there is a Grace GB300 as well, which combines the Grace chip with NVIDIA GPUs. At this point, I'm going to invite my colleague, Lan Wu, to talk about her partnership with Dell.
As we know, VCF support either direct path I/O or virtual GPU as the different option for our customer to deploy their AI data center. And here I demonstrate using vGPU to run AI application in VCF. Here we deploy AI private cloud with Dell hardware and NVIDIA H200 GPU using virtual GPU. And for this purpose, we collaborate with Dell and NVIDIA on benchmarking MLPerf inference workloads on Dell XE9680 servers with 8 H200 GPUs. We use a vGPU in VCF for our benchmarking purpose. vGPU provide a number of different benefits compared to a bare metal or direct path I/O. It supports device group with NVLink, NVSwitch. It means you can have one VM with own GPU, or you can have multiple VM with 2 or 4 GPU in the system. With this, it helps to sizing a VM that fit with the demand of the workload, provide full isolation among VMs. For the case of a smaller AI workload like Llama 7 billion or 8 billion parameter, doesn't require entire memory GPU like H200 or B200. You can have multiple VM sharing single GPU that run that smaller AI workload. And another benefit is with vGPU, it supports some management feature in VCF like suspend, resume, vMotion. In the case of like multi-tenancy, if you have the different workload run on two different VM, where each VM have a different guest OS, and even it have different workload, either AI or non-AI, then vGPU support this configuration very well. In order to demonstrate the benefit of virtual GPU in VCF, we run MLPerf inference with 8 H200 GPUs in two cases, bare metal and virtual, with the configuration that I show here. In the case of virtual, we create a VM and we allocate 25% of CPU core to this VM. In this system, it has 3 terabyte and we allocate 2 terabyte, which is 67% of memory. In case bare metal, we use full resource. In case of virtual, that we use a portion of CPU and memory. For the comparison between virtual and bare metal, we present a normalized throughput compare with bare metal, and you can see here there are no differences between virtual and bare metal. In the case of virtual, we use less resource without sacrifice of the performance. And you can use the remaining compute resource, including CPU memory for other workloads, showcase the benefit of VCF for managing AI data centers. For the previous slide, I compare with bare metal result that they'll submit at ML Commons. But beside that, we also test ML inference with more workloads. For example, Llama 4-5 billion parameter, which is a very large model, to showcase that it works well for either large or medium size. We also have the result for stable diffusion, which is image generation, to demonstrate that it works with different type of workload, not just large language model. In the case of when your data center doesn't have GPU resource or not have enough GPU resource for your application, then you can leverage CPU for running AI workload as well. The system we use for testing here include Xeon 6787P with 86 cores. In case of bare metal and in virtual, we allocate all the CPU, memory, and other resource For the AI ML domain, that multiple different workload. A lot of those workload is using smaller model, and some of set of workload that we test here, including Llama 8 billion or DRM for recommendation engine, Jira's graph neural network, text-to-speech object detection, a variety different workload that you can run using CPU. The result for MLPub inference, here you can see that most of workload provide very close to bare metal performance. It just showcase that you can use CPU for a rich set of AI application as well. This also wrap up our blog today, in which we demonstrate different options for deploy AI workload in VCF. It provides very great performance, and in addition, combine the benefit of using NVIDIA GPU, NVIDIA AI enterprise software, CPU, VMware AI private foundation. We would like to thank SuperMicro, Dell, NVIDIA, Intel provide tremendous support for our effort on running MLPub Inference in VCF. If you have any question, feel free to reach out to us. Thank you.
Yeah, Lon, great job. Uday as well. Thank you. I just wanted to stress again that all these results showed that VCF platform can provide near bare metal performance for your AI and ML workloads, as shown with all this great work that Uday and Lon are showcasing in this video blog today. We're going to have additional links below this video to follow up with. With that, I'd like to thank everybody for tuning in, and I look forward to seeing you on another episode of the Extreme Performance Series soon.